So let's connect everything we've done so far in terms of variation, slope, and first differences. All right, so we're going to connect everything we know about slopes, equations, graphs, tables of values, constant of variation, and first differences. So we're going from, if we want to go from graph to an equation. So the example we have here is this, the graph shows the relationship between the volume of gasoline remaining in a car's fuel tank and the distance driven. We need to calculate the slope and describe its meaning. So we're starting here and we end all the way down here. So the values that we have, well, my x value for this is 0, my y value is 65, I start with 65 liters. My other point that I'm going to use is down here. My x value is 500, I traveled 500 kilometers, and I now have 0 liters of gas. So if I'm looking to calculate the slope and describe its meaning, well, I need to find the difference between my y values and the difference between my x values. So in this case, my y2 is here, my y1 is here. I'm looking for the rate of change between these 2 points specifically. Right? So what's the change of going up and down, and what's the change of going left and right? So my change in up and down is my y2 minus my y1 value. That'll give me this distance. And then my change in left and right would be my x2 value minus my x1 value. So I end up getting 0 minus 65 is equal to 500 minus 0, which means that negative 65 over 500. Or it took us 65 liters, we went through 65 liters to travel 500 kilometers. And if I break that down into how many liters per 100 kilometers, I use 13 liters for every 100 kilometers. And if I break that down into how many per 1 kilometer, I actually use 0.13 liters for every kilometer. Determine the vertical intercept. Well, where does this line touch the y-axis? It touches the y-axis right here at 65. So the y-intercept, which is the vertical intercept, the y-intercept is 0 and 65, or we write our b value to be 65. Now we need to write an equation for this relationship. The equation that we're going to use is y in the form y equals mx plus b, and we need to know two things. We need to know what our m value is, and we need to know what our b value is. Since we know those, we can create the equation by simply plugging in those values. Y equals, in this case, it's negative 0.13, x plus 65. If we go from an equation to a graph, make a table of values and graph the relation y equals 2x minus 5. Draw a right triangle on your graph to find the slope. I'll do that later. So in my table of values, my x values, I'm just going to write for 0, 1, 2, and 3. So when x is 0, when x is 1, when x is 2, and when x is 3. How I find my y values? Well, I simply plug in my x value into the equation. So my y value is equal to 2 times whatever that x value is minus 5. And the example that I've done is right here. In the equation, 2x minus 5, I plug in the known value for x that I'm given. In this case is 1. So when I plug this x value into my equation, I can now go ahead and solve for my y value. So 2 times 1 minus 5 is equal to 2 minus 5, which is equal to negative 3. And I do that for all the other values in my table of values. When I plug in for an x value of 2 into my equation, I end up getting negative 1. 2 times 2 is 4, minus 5 is negative 1. And I keep that pattern going. I just simply plug in those x values for when x appears in that equation to get my y value. So I have all my y values. When x is 0, my y value is 5. When x is 1, my y value is negative 3. X is 2, y is negative 1. X is 3, y is 1. I go ahead and enter those or plot those on my graph. So when x is 0, y is negative 5. When x is 1, negative 3. When x is 2, negative 1. And we can see how we create this line here. Now I'm looking for the slope. The slope would be the rise over the run, right? So how much it changes going up and down, over how much it goes left and right. Or if you remember from direct and partial variation, I'm looking for the independent variable divided by, the dependent variable divided by the independent variable, right? So rise over run, or y over x. So in this case, in order to go from one point that I have to another point, I have to go up 2 and then over 1. So my rise is 1, 2, and my run is 1. So I would write it as 2 over 1, which would mean that I can write the slope is 2. So what do we notice? The slope and constant of variation are the same, right? And we talked about that when we were doing direct and partial variation. The rule of 4, a mathematical relation, like a line, can be described in 4 ways. You have an equation, a graph, table of values, and words. These all represent the same line. All the information is the same even though they look different. So, an example of the rule of 4. Jacques earns $25 per day plus $9 per 100 flyers for delivering advertising flyers. This is an example of using words to describe a relation. Use the rule of 4 to describe this relation in 3 other ways. So this description is words. They just use words here, so that is the first method. The second method would be table of values. So our independent would be the number of flyers, and his dependent is how much he earns. So if he sells 100 flyers, 200 flyers, 300 flyers, 400 flyers, how much does he earn? Well, I know that he earns $25 plus $9 for every 100. So after 100, I'm adding those together. So I get 25 plus 9 would give me 34. Plus another 9, plus another 9, plus another 9 for every 100 flyers that he sells. So this would be our table of values. Our method 3 would be an equation. And the equation would be in the form y equals mx plus b, where we know the y-intercept and the rate of change, or the slope. The rate of change is 9 for every 100, $9 for every 100. So this equation is y equals 9 over 100 x plus 25, right? He's paid $25 a day. That is our constant, or that is where he will. That's where he always gets paid. And then in a graph, I have number of flyers, and then how much he earns. I know that he starts at 25, and then for every 100 flyers, he earns $9. 100 flyers, $9. 100 flyers, $9. So we can see that linear relation, or we can see that slope of rise over run in order to determine how many he's going to earn later on. So how these all connect? The constant of variation is also the slope of a linear relation. Slope can be symbolized as m equals the change in y over the change in x, right? Or slope is equal to y2 minus y1 over x2 minus x1. Or we have 2 points, the second y value minus the first y value, all over the second x value minus the first x value. A line has an equation of the form y equals mx plus b, where m represents the slope and b represents the vertical intercept, or what we will be calling the y-intercept.